So we continue in chapter 6. We're now at section 6.4, which is areas of surfaces of revolution. So the idea of surface area. Now I have a picture here showing a very simplified version. If we were to just create a cylinder here, it says a cylindrical surface is generated by rotating this line segment about the x-axis. If you were to then take that shape that's generated and flatten it out, you would have a rectangular shape. The length of it would be the circumference of the circle, which would be 2 pi times the radius. In this case, the radius is y, so that's where the 2 pi y comes from. And then the width of it is the distance of this line segment, delta x. So if you want to find the surface area, you would multiply the two together. Now, most of the time when we're going to be finding these surface areas, we're not going to be starting with a very simple horizontal line segment, but we're going to have a curve which might have some dips and some valleys in it. So the formula here for surface area is going to be very similar, and you're going to see a lot of similarities with the formula that was introduced in the last section for the arc length. So you can see here, surface area is the integral from a to b of 2 pi y, there's that length, and then the square root of 1 plus dy dx squared, that's going to be our arc length. So you're going to recognize this again from that last section. So we're going to use this formula to find surface area for a given curve. So here we're starting out with a half circle. It says, find the area of the surface generated by revolving the curve y equals the square root of 2x minus x squared about the x-axis. And it gives us that x is between 0.5 and 1.5. So in the graph here that I have pictured, we're actually just going to be looking at this region here. So kind of the middle of this circle, or this half circle, we're going to revolve around the x-axis. So to use this formula here, I do need that derivative. I need that dy dx. And I'm going to come over here underneath the graph and go ahead and do that. So to find that derivative, just going to use the chain rule. So we've got 1/2 times 2x minus x squared to the negative 1/2 power times 2 minus 2x. If I take that 1/2 and distribute it across the second set of parentheses, I'm left with 1 minus x. So combining that with this negative exponent, bringing the 2x minus x squared part to the denominator, it's going to leave me with this, 1 minus x over the square root of 2x minus x squared. So there is my derivative. So now I can go ahead into the formula. Surface area is the integral from 0.5 to 1.5 of 2 pi times the square root of 2x minus x squared, that's our y value, times the square root of 1 plus the derivative squared. So we have 1 minus x over the square root of 2x minus x squared, whole thing squared dx. Now this one starts out looking like a bit of a hot mess, but bear with me for a minute because a lot of things are going to cancel out. The 2 pi, if you want to, you can bring it in front of your integral. I might just leave mine be, but it's not going to impact anything one way or the other right now. I actually want to focus on the second radical here. So let me go ahead and write the first part out one more time. I'm going to come back to the 1 in just a second. I want to focus here. I've got 1 minus x squared over the square root of 2x minus x squared squared. So in that numerator, I can go ahead and square the quantity 1 minus x. So that is going to give me 1 minus 2x plus x squared. In the denominator, I'm just going to have 2x minus x squared. Now I said I'd come back to the 1, and I'm going to do that now. I want to have a common denominator. I want to be able to add these things. So instead of a 1, I'm going to write it as 2x minus x squared over 2x minus x squared. Let me get my plus sign in there. Now that they have that common denominator, I go ahead and add the numerators. Well, you'll notice here we have 2x minus 2x, negative x squared plus x squared. So in the numerator, everything else cancels out. I'm just left with a 1. So let me just go ahead and rewrite that, just showing what it's going to look like. So when I bring that together as one fraction, I just have 1 over 2x minus x squared. Now, because I really don't want to rewrite this whole thing, can take these square roots individually. So the square root of 1 is 1, and the square root of the denominator is the square root of the denominator. Now at this point, the square root of 2x minus x squared that's kind of just been hanging around, this cancels with that denominator. So what I'm left with is just 2 pi dx. And remember that 2 pi can go in front of the integral if you want it to. When we integrate, we have 2 pi times x, and we're going to evaluate that from 0.5 to 1.5. So when we subtract, we get 2 pi times 1. So here the surface area is just 2 pi.